Hello, my name is Paulo Roque. I'm a systems applications engineer with Analog Devices, working on the energy storage systems team. And I'm excited to talk to you today about my demo on lithium-ion battery energy storage systems. As the world shifts away from using fossil fuels, a need arises for using other sources of energy. And for use of lithium-ion batteries, you need to develop system solutions that will effectively measure the battery. With these solutions then coming out, becoming mainstream, Analog is focused on addressing those needs by developing those energy storage systems for industrial applications and those specific and those markets. I see three key challenges here. First, it's a new technology, so there are many challenges associated with the deployment, the manufacturing, the scalability of the solutions. Secondly, there is safety as well. So as the system becomes more and more powerful and the density in batteries increases, the need for safety gets more and more significant. And thirdly, I see a challenge there regarding to the long-term stability of the systems, and which also need to be well addressed and developed right now. ADI is developing system-level solutions for the energy storage market. Part of that solution is the BMS controller. The BMS controller is a board or a platform we've developed that works with our BMS chips and or with our BMS analog front ends, and is able to communicate with them in an isolated fashion. So implements full communication, full isolation, and does enabling a safe system. And we also implement the software, and we supply demo graphical user interfaces that customers can use for quick deployment in their systems, thus enabling them to go faster to the market. Here what we have is a battery management controller board, and in this board we integrate a legacy Maxim microcontroller named the Max 32626, located here. And with that microcontroller, we communicate with the analog front-end boards in an isolated fashion using the ISO-SPI chips, LTC6820 produced by Analog, that you see there beside that blinking light. And that is connected to the analog front-end through an isolation battery here through a transformer. We have this board fully isolated from the high voltage side, and we have here analog front ends that Analog develops, especially the AD BMS 1818, which is an industrial solution for our BMS chips. Through battery emulators, we're able to simulate the voltages on the analog front ends. And as we turn the knob on our battery emulator, you can watch the voltages changing on our graphs called user interface. Our solution allows ease of implementation for the customer. They can base their system on our system or use our system. It allows also for higher accuracy. Our system has got higher accuracy because it's able to communicate with Analog's BMS parts, which are high accuracy. It's also a system that enables scalability. The system can be easily connected to multiple Analog front ends, and also enable safety through isolation and taking care of the safety as well, promoting the isolation, which is a key parameter for ESS systems. In Analog, we are committed to a sustainable future. Through that, our plan is to contribute to the decarbonization of the energy grids, and that will play a significant role in achieving our goals towards a much greener world. If you'd like to know more about our system-level solutions and the things we have been developing, please visit our website, analog.com.